Right, then good morning. And before I start, I'd like to talk a little bit, give you a short introduction about myself as well. I have been with the Schwarz Group for the last 7 years, and the first 4 years I have been responsible within our manufacturing division for the whole application management, support, development, operation. And 3 years ago, I moved to the headquarters and started the team AI industry, and we are focusing on AI topics throughout our industry divisions. And I was employee number 1 within this team and did start many prototypes, and so far we were quite lucky. And actually today I want to talk about one prototype which is in rollout, and in beginning of next year this prototype will not be anymore a prototype but a working product, and it was quite interesting. And Carl is not here, right? Yesterday he talked about computer vision within the manufacturing industry as well as food waste, and that will be basically today my presentation. And he said it's quite easy to do this within the manufacturing. I do have to disagree, but I will talk about this later. So who is this Schwarz Group? Many people don't know the name Schwarz Group, but many do know one of the divisions within the Schwarz Group, which is Lidl. I'm very difficult for me to pronounce it in English, but it's in German, it's Lidl. And we also have the other retailer, which is Kaufland, and this is one of the main parts within the Schwarz Group. However, there are 2 more large divisions. The one division is Preseo, which is basically the waste management recycling company, and in the last few years this got a major player within the European waste management area. As well, why I started my journey within the Schwarz Group is the Schwarz Production division, and in Germany we currently have 15 factories, and one of these factories is one of the largest ice cream factory. We have 5 bottlers where we fill up water and other beverages. And our first factory outside of Europe is going to build here in England, and it will be in production in the next few months, I think. Yeah, the latest factory was one of Europe's largest coffee roastery, where we actually have one of our first use cases also in the testing system. However, today I want to talk about the bakery process, and which is also one of the largest factory in Germany, if not even in Europe. So we are living here, as you see, the circular economy. We are a very unique position where we have everything beginning from the production, manufacturing, throughout the retailing, back to the recycling management processes. And this is quite interesting for us as AI, because we get the data from the manufacturing, we get the data from retail and recycling. So I really don't have a data problem, I more have a resource problem, but later to this. So a few numbers for our company. We have around 550,000 employees and over 13,000 stores throughout the world, and a revenue of 133 billion euros. And one which makes me really happy and really looking forward to it, we really think about sustainability within our company, and it's important. And as you see, we have 4 pillars here. The 4 pillars are the people side of the sustainability, product quality, and circular system. As you see, even in our strategy with retailing, recycling, and manufacturing, we're living it, and not just talking about it. And today, the main thing for me is this cautious use of materials, especially in bakery goods. So the case study. Today it's a case study, some ideas how we tackle the problem about waste management within the bakery process. As you see here, it's an image I got from our internal picture database, but is how do you reduce food waste within a bakery process? We use milk and dough, and it's very precious goods. So we really need to make sure, not just from a financial point, but also from a sustainable point of, that we are able to get the most out of this process. In order to start this, let's talk a little bit about the manufacturing process. As you see here on this picture, it's the whole process from the beginning where you have the dough, you mix the dough, then afterwards you form the breads, and it will be transported to a pre-baked process environment, and afterwards it gets shipped to the retail stores. And we really need to measure this process. Why do we need to measure the process? Let's assume we put 100 kilogram of dough in the front. Here I put the numbers 220 pounds, so I hope that's correct. So I'm not familiar with this. But at the end, we only get out 90 breads, but we should get out 100 breads. However, sure, we have some water loss within this process, but in order to not make it too complex, I just assumed we have here 100 breads as a goal, but we only get out 90. So what you do? Where do you lose this bread? It's there are many reasons for this, mostly mechanical reasons, where something fell down or something gets stuck, and at the end you can't use this bread anymore. So we going to look into the process and start. Okay, at the beginning you have only 100 breads. So how do we count this bread? And then we have at the end 100 breads. So let's see. There we go. Okay. How do we count this bread? We have, as you can see as this picture, it's very easy. Breads are very lined in one row. And to look at this process, you just take a laser counter. You build it in, you create some metal frame, and every time the laser is interrupted, you count. It's very cheap. The counter costs under 100 euros and 100 pounds. If you have a very good purchase manager, you get it maybe for 50. You just plug it into a PLC, and this connects to the line management system, and it will operate for many years. And with very little of support and maintenance. You have to clean it sometimes, and sometimes it will be turned a little bit away, but you send an engineer there or somebody who runs the line, and he can easily repair it. But what happens at other places of the whole system, where you look, where you still have the breads, it's 100 breads and 90 breads. So this might have a different view, and the view, as you can see here, is different, where you can't use any laser counters anymore. So it's a picture of our internal database. It's actually not our real factory, but it's not quite different. And how do we count this one? So the only thing here is to use computer vision. And how does this look like? We do have here a different setup. You need to build a whole metal frame around this line, and to record this. And Carl mentioned, yeah, it's very easy. Well, it's not that easy, because you're working in a very clean environment. It's not a ship manufacturing where you don't have any air destruction. However, it's still food, and the food and needs to be preserved and clean. And therefore, we built here a custom-built metal frame throughout our lines. And one important thing is also the lighting structure. At some points, you just put the cameras in there and works very well, very fine. But at other locations, you really need the lighting in order to count it correctly. So the second part is once you have the metal frame set up with the lighting, the cameras, you need to take care of the data connection. So you could send it into the data center on the factory level, but you have the huge problem because if you put in new network cables, you have a fire hazard problem. Every connection through the wall or every other connection is certified by the fire department, so you can't just tear anything open. So you need to have the compute power directly at the line. And therefore, we built here a custom PC with our hardware colleagues, and I will talk about it in the next picture. But setting this up, getting the approval from everyone was quite difficult. Also, getting the worker council within Germany, it was a good way. Karen, I think he talked about it, and this was very easy for him. In Asia, in Germany, it wasn't that, but we got the approval, and we are now in the process of rolling the system out. But the main thing, actually, which took us much time, was the setup of the at the line correctly. We needed to get into the switch cabinet, which was very close to the line. And as you see here on the left side, it's a picture. It's also just an example, but in the switching cabinet, it's not very big. You have only a few spaces left, and so you see here we had our network cable, and our camera is provided over power over Ethernet, but then we have to be able to operate this 24/7, and throughout the whole year, only on Christmas Day is the factory is closed. So, but everything it needs to be done. So what we thought about it, we have to have a very flexible system. So we started with our hardware. The hardware is standard, however, custom built. And on top of this custom build, we looked into our setup, and we decided to use here a Linux version. On top, we implemented our NVIDIA drivers and our VIA libraries, and then we got our Docker runtime. And together, this is our golden image where we can use and send it throughout our devices. However, in order to be very flexible, we decided that all our applications we want to send out are also Docker-based and container-based. Therefore, we decided to use a Kubernetes agent. We didn't use the large Kubernetes. We decided for K3s, which is way smaller for the deployment process. And the main reason is also it's as strange as this here. We don't have this large data internet connection into the cloud, and we really need to look at our size of our container as well. The NVIDIA libraries, as you might know, it's almost 8 GB large. So we need to look into how to skim the size of our images down. So on top of this are actually our containers, which we build. We have the ingest container, we have the interference container, and also our communication container. So at the end, we did link our libraries into our container, and on top of it was our application and how to count this together. That's the whole system. Is our AI at Stack, and we are very flexible with this. We can run this in every device where we deployed it. And also our support process is quite unique. If this system breaks down, we just tear out the hardware, plug in new hardware. The only thing is the first level support can identify it right away, and the process starts automatically. And everything from the cloud down to the system is automatically deployed, and it will run as soon as all the containers are up there, and starts automatically. In order to get this down, we also looked into our deployment process. We did train in the cloud. We also started, beginning of this year, our own hyperscaler. It's called StackIt. And so the vision is, of course, to compete with the big 2 or 3 ones. And however, we are it's a very early process here, and right now we are still using one of the 3 major hyperscaler. And once we build our process in the cloud, our deployment pipeline, our container, we automatically send it to the factory data center, and from the factory data center, it goes out to all the industrial PCs on the line. And this process not only enables us to do this in the manufacturing plants, but also for all the other divisions, we can use the same architecture, the same deployment process, the same support processes, which is with this high synergies throughout the company. And we are in the process of rolling this out. So I'm neither in the development stage, not in the product stage, but in the rollout process. And beginning of next year, we actually have the first lines in the product. So how does this look like? You see here it's a picture. We have the bread, and we're not only detecting the bread, we're classifying the bread, and we tracking the bread and throughout, and then we have our counter. And the possibilities for this are not just counting, but you also could look into this one for quality issues. And the quality issues, like if there are 2 breads stick together, or if they're just a half of a bread, we can easily recognize this and have a live and in real-time monitoring. So our colleagues are very happy, and they really look forward for this tool. So they are able to track throughout the manufacturing processes what we are building, what we are manufacturing. And so we have a combination now from the beginning where we have the dough, we have the laser pointers, which are installed by our colleagues in the factory. And then at the end, we have multiple computer vision stations where we record it, and the product is therefore very well received from our colleagues at the factory level. Yeah, at the end, we're leaving the factory, but we do think it's a whole process. As I said in the beginning, we not only look at the factory, but we also look at the store itself. We, therefore, the demand forecasting of our bakery goods within our Lidl stores, as well as store optimization for the availability. It's AI processed, it's AI technology behind it. So that basically was my presentation for today. Any questions?
Thank you. It was quite interesting how you showed that video of tracking the bread and also identifying defects within the bread, I suppose, in the production line. Now, my question is, how have you implemented that system within the manufacturing line? Is it like a static camera that stays above the conveyor belt at all times and the conveyor belt keeps moving, or is it are both moving components where conveyor belt moves and camera also moves alongside it? Because I see that you also have a window set up there where you probably track whether how many breads are within this particular window at a certain time, have we already counted this particular bread? And probably when the bread moves away from that window, you stop counting that because you've already counted that while it was within the window once, right?
It's a fixed position, the camera. So they are throughout the whole line. There are counting stations. So you know when it was, as I said in the beginning, you have the dough line, you have the bake line, and then at the end you have the putting together into the bag. So it's a fixed line. So you know at each stop what kind of how many kinds you counted. And if you have 90 at the beginning and 80, you lose somewhere bread. So the process engineer goes in there and tries to find where do we lose currently the bread. So it's always
they probably dropped somewhere from the conveyor belt.
Somewhere it has somewhere it's getting loose, but
So count is the most important.
Counting is the most important thing. Yeah.
Good, thank you.
For right now, maybe in the future we have different features as well.
Hi, Mark. Thanks for the presentation. So I'm sure that you iterated, or the team iterated a lot on the software side, right? Get the models, etc., accurate to where now they can be deployed. What about? Can you talk a little bit about the hardware? So you showed your stack a little while ago. You've got the industrial Jetson setup, but then can you talk about, let's say, the camera and the Jetson setup? Did you have to go through iterations to find the right mix?
Yes.
Because I mean, it says something on the sticker that this machine will support X devices or whatever, this much capacity. But how does it work in practice? Could you talk to that a little bit?
It was actually the hardest part. So the AI part was very fast. The original AI model was in 4 hours done. That's it. But the camera and setting up everything with the hardware was a quite long way. So we had different suppliers, looked at them, got them into I actually got a warehouse. In the warehouse, I everything built from scratch. I put in a conveyor belt, put all the cameras in there, and we tested it and tried to see which works best. And then we scaled it down until we had one supplier for the hardware and one camera supplier. And right now, it's just working out the latest kinks. It's always the biggest problem right now is if somebody gets out a patch and says, "Okay, here, please install because we have a problem," and a minute later, nothing works. So, yeah.
Okay. Thanks, Mark, for presentation. Could you tell us? I take it the main goal is to count bread. But do you use information about defects in your bread, and how do you use it, if any? And another question is, do you use demand forecast in production?
Yeah, so for the defects, yeah, we could count them. We already have the AI in place, but as we heard many times before, just focus on one thing and be very, very good in this one thing. So we said to the business, hey, we just start with the counting. Let's not get sidetracked and defects or any other issues. We focus on counting, get this out, and next year when we have it rolled out, let's see, we can put additional features into the AI model. And demand forecast for this one, no, everything what we produce gets into the store, but the stores itself, we have the demand forecast. So each store doesn't need 100 breads daily, the one needs 80, the other needs 110, so the stores itself have their own demand forecasts.
Thanks, Mark, for a very interesting presentation. I have two related questions that are also related maybe to the context of deploying these technologies in Germany. So first of all, like from your perspective or maybe experience, like what's the reaction from the workforce, so in the factory, in terms of like deploying these AI modules that essentially replace people that work in that production line? And the second related question also in terms of like privacy. So putting these kind of modules in stores that optimize I guess, the store experience. So how do you deal with the privacy issues of putting cameras there?
Well, at the beginning, right now, we really don't count at all. Or sometimes we have people sitting there and count, but it's, as you see one of the pictures, it's very difficult if you have 100 breads. One of the lines, I guess, it's 15,000 breads an hour, so it's difficult to count this one. Therefore, at the end, yeah, you're sure you have your pellets and which go out, and you can estimate how many breads are in there. But you don't know it throughout the process, so you don't. It's very difficult to find where have the mechanical failures. And for the privacy issues, as you see on the picture or on the video, there's no human face. There's not even a hand involved within the video stream. And so we talked with the worker council, and they approved it, and they want to know what kind of video technology. However, the worker council were very fine with it that there's not any human interaction on the camera. Also, if you have the metal construct, it's really the cameras from the top, and the sides are cut out directly on the camera, so you even don't have any human hands recognition or any other parts.
Thank you very much, Mark.
You're welcome.